Hi class, let's take a look at example 3. So take a second and read it. And one of the most important parts that of this problem that I actually highlighted is in the second actual portion of the problem, or the second sentence. That would be that they're telling us that the standard deviation of all credit scores, in this case, this is the value of sigma. It's 58.9. And then the actual level of the test, this is alpha, which is equal to 0.01. So to determine the type of test that we're going to be performing, since we have sigma, so let me just write it here. Sigma is equal to 58.9. Then in this case, this is going to be a C test. Now, let's take a look at the actual claim that they're providing on this one. So the actual claim, it's going to be, and they say that, well, the actual population has a mean greater than 678. So mu, it's going to be greater than 678. And this is on the credit scores. So let me just write it as FICO scores. Now, once we have the claim, we need to actually state both of the hypotheses. So HO and technically HA. And for these two, since the claim is on greater, we're going to be doing a right tail test. So let me go to page 1 so you can see it. So in page 1, the actual claim happens to be, in this case, let me erase all of this, we don't need it, a greater. So we're looking at this actual scenario, which is going to be a right tail test. Our region for the actual population, it's going to be this one. So let me go back to the problem. So our HO, I'm just going to write it as, well, equal to 678. So 678, and then your H. So mu is equal to 678. And then your HA, mu is greater than 678. Now, let's take a look at the, at the actual region. So in this case, the critical values. Now, the values that we have is that technically C is equal to 0.99. This is because alpha is equal to 0.01. And the most important part on this portion of the problem is that the claim is a right tail test. So the critical region, it's going to look like this sketch right here. So we're technically looking, when we mention critical values, we're looking at the actual population. So in this case, we're going to be looking at a bell-shaped curve. We need to find this value. And because it's a right tail test, we know that this portion happens to be technically alpha of 0.01. Now, to find the specific critical value, we're going to be running the following command. So let me clear this up, and you're going to go to second and technically distributions. Then you're going to run the inverse norm distribution. For this particular one, well, remember that the inverse norm only works on area to the left. So this is 0.99, which is technically your C value. Keep in mind that your critical values are not identical to the ones that we did on the previous section. So in this case, you're looking at 0.99. Wait, I don't think I put 0.99. So 0.99. And the distribution is technically standard normal. So please run it and see if you're matching. So critical value happens to be a z value, which is approximately 2.32. So 2.32. Now remember what I mentioned about the actual region depending on the actual test statistic. So if your test statistic lies in this area, you're simply going to reject HO. If it lands on this area, you're going to say fail to reject. Technically HO. That would be for the test statistic. At the moment, since we're looking at, well, critical values, you're looking at the actual population. Now let's take a look at the sample. And let me just get a summary of the sample. So in this case, let me get the sample. And if you don't mind, please run me a one variable stats. Let me double check that I have all values. And I think we're good. The last value should be there, 802. So please write me a one variable stats and see if you're matching with the actual results of the sample. So in this case, we're looking at a total of 12 values. So n is equal to 12 values. The mean, let's see, let's round to 2 decimal places, is 680.58. The standard deviation, it's going to be 112.98. So 112.98. Let me circle it because this is what we're going to be actually comparing. So at this point, we're going to be looking at the actual shape of the actual sample, except that we're not going to draw it. We're just going to calculate the test statistic. Now, the test statistic, and I need you to label this. It's going to be a C-score that's going to have the following values. This is x minus mu divided by sigma over the square root of n. And I'm getting the actual test statistic from technically page 1. So we're looking at this actual formula since we have the values of sigma known, and we're looking at a right tail test. So for this particular one, please evaluate, and we'll compare values in a minute. So this is going to be equal to the actual mean of the sample was 680.58 minus the mean, which is going to be 678 over the square root. Over the values of sigma. Sigma is 58.9 over the square root of, in this case, 12. So please take a second and calculate this one. We'll compare values in a minute. And this is a 678. and I'm getting that this is approximately 0.1517. Now, what you're going to be comparing on your final answer is where this actually happens to land based on the population. Since the actual region, it's cut off at, well, in this case, at 2.32, we landed on the fail to reject. So from here, our main conclusion is going to be to fail to reject HO and you can simply say because the test statistic of C ended up being 0.1517. It's less than 2.32, which is equal to technically C, and in this case the critical value. So let me write it as the CV. And what we're explaining here is that it's basically to the left of the critical value. Therefore, we land in our fail to reject region. Now, let me actually show you how to run this with a calculator. So, since you already have everything as an actual list, go to stats and then technically go to test, do a z-test, and then make sure that you have all the information, 678 for the sample. Actually, the standard deviation is 58.9, and then the mean is actually there. We have a total of 12 values. It's a right tail test, and what you're gonna see here is that the actual test statistic is here. That's going to be your p-value. So the 0.15 is what we found here while doing this really messy calculation. Now, here's your p-value, 0.43. So for the actual value for part B, this is supposed to be part B. Well, the p-value, it's approximately, and we're given in this case, it's 0.4396. Now, in terms of the sketch, this is what we're looking at. We're looking at a sketch of the actual sample. The test statistic ended up being 0.1517. This shaded region represents the actual p-value. So it's actually sufficient just to run it with the calculator without having to actually well, finding the normal CDF for that area. In this case, the calculator gives it in this format as the 0.4396. 4 decimal places will be sufficient to round. Once again, on this specific problem, if we mention in your final conclusion that you failed to reject HO, that means that this is not false. We don't have sufficient evidence that mu is greater than 678. In this case, it's more likely that mu is equal to the 678, so this claim is technically not valid. A basic statement of fail to reject HO and then the position of the critical value with the test statistic will be sufficient.